welcome to week 4 of Pearland ISD's Link and Learn. I'm your host again, Mrs. Garza, 4th grade teacher for Silver Lake Elementary, and I'm excited because we're going to be drinking some agua. You're going to help me solve a problem. How many ounces of water should I be drinking a day? Stay tuned. This week's teach for Pearland ISD's Link and Learn 4th grade math edition is Input-Output Tables, TEAC 4.5b. Represent problems using an input-output table and numerical expressions to generate a number pattern that follows a given rule, representing the relationship of the values in the resulting sequence and their position in the sequence. Here we go. Alrighty, boys and girls, we're going to solve a problem today. How many ounces of water should we be all drinking a day? So what I have in front of us, before we start getting into the input-output table in our papers, I wanted to show you what we're going to be figuring out, okay? So these are 8 glasses, right? But I have filled them up each with 8 ounces of water. So if this is a recommended daily intake of water that we should be drinking to keep ourselves hydrated, especially out in the hot sun as the summer has barely started, this is how many ounces we should be drinking a day. Well, how many ounces is this? How do I figure this out? Let's get to our input-output table. Okay, kiddos, some new terminology, some new vocabulary that you learned this year in 4th grade as opposed in 3rd grade was instead of our input, it is also known as position. And instead of rule, it is known as our numerical expression. And instead of our output, it is known as our value. So here in 4th grade, I know y'all did a lot of practicing with these terms, this new vocabulary. This is very important as these are the types of words, not these are the types, but these are the words that you will be seeing, or the vocabulary that you will be seeing associated with input-output tables, okay? So we can't just say input and output. It really means position, value. What is a rule? What is the numerical expression, okay? So here's my question. How many ounces of water should I, or really should all of us, be drinking in a day? And then we're going to also solve what is the numerical expression for this question. And what I like to do in my class is I like to show the kiddos to use it using a variable and then also adding their numerical expression with variables, okay? Because that's what you're going to be doing as you get older. Okay, so here we go. So I had said that we have these 8 glasses of water, right? And I am trying to figure out what that means, right? So my position for this one, as I know that I had already said that my 1 glass of water, really one because not full, it's just the half, 1 ounce or 1 cup, 1 cup, okay, 1 cup equals, how many ounces did I put in here? 8 ounces, right? So 8 ounces, okay? So my position here means my input, my cup. I like to put that there too to show you. Meaning I did something here and then magically my value is going to be the output, which is the amount of ounces, okay? So in this input-output table, my position means my cup. My numerical expression, I haven't come to that yet, but the value, because I'm just showing you that the 1, what that 1 meant, the value I know, because I just said that it was 8 ounces that I put in. So my position means cup, my value means ounces. Then something magical happened that I put this number in and this number came out. What did I do? Okay, so I either added 7, right, to give me 8, or I multiply times 8 to give 1 times 8 to give me 8, okay? So let's go ahead. I have my 1, and now I have my 2, okay? So 2 cups, my position 2. Numerical expression, I'm not going to say that yet, but my value, well, 8 and 8 is what? 16. I just doubled that up, right? So if I had said, let's just say if I had said that my numerical expression is cup plus 7 equals my value 8, would that be the same for this one here? If I said This one was 1. 1 plus 7. If I said 2 plus 7, does that give me 16? No, it doesn't. So that wouldn't be my numerical expression, right? So then I know it's going up, so I know that it's not going to be subtraction or division. So I would also use what? Multiplication. You got it, okay? So here is 1. 1 times 8 equals 8. Yep. My position, which is the cups, times 8 gives me 16. Yep. So you figured it out, right? We say that our numerical expression is really whatever we put as our cups times 8, because 8 ounces in each what? Cup. Okay? So here we have numero 3. Numero 3. Mrs. Garza is a little bilingual, not a little, a lot, and I'm very happy to share it. Okay, so 3 cups. 3 cups times 8 ounces in each cup gives you what? What is that number? What is 3 times 8? Boys, help me out. What's 3 times 8?
24.
Very good. Nico screamed 24. Thank you, son. Okay, next. Number 4. 4 cups. That is my position. If I put my numerical expression, the magic formula here, 4 cups times 8 ounces in each cup, what is that, boys? Help me. 4 times 8. 32. Good job. See, I'm doing some teaching here at home too. Alrighty, we have cup number 5. Cup 5, that's position number 5. And I put in my numerical expression, 5 cups times 8 ounces in each cup gives you what? 40 ounces. Okay, number 6. Here's my 6. Cup number 6. 6 cups times 8 in each, 8 ounces in each cups gives you what? 48. Okay, now I have cup number 7. 7 is my position. I put in my numerical expression, 7 cups times 8 ounces in each cups gives you what? 56. Thank you, my producer back there, okay? And cup number what? 8. 8, that is our magic number right there, 8. 8 times 8 is 64. So guess what, boys and girls? We need to be drinking 64 ounces a day. We should be really drinking more than that, but 64 ounces is what we should be drinking. So do we answer our question? How many ounces of water should you or me or everybody be drinking in a day? Well, we should at least be drinking 64 ounces. Okay. What is a numerical expression for this question? Okay, so basically when you were in 3rd grade, you just knew to say like times 8, okay, because that's the rule. But when we're now in 4th grade and now we're going to be using a lot of variables, getting ready for our algebra, you should be saying how I put the position, that was our cups. So what I like to do is I like to show my students to do this. Tell them to put C for cups, cup, because whatever you substitute for the C is right here, cups times 8, because each cup has 8 ounces of water, equals ounce, or ounces. So I would put ounces, okay? So whatever you put here, like 1 cup times 8 gives you 8 ounces, right? 2 cups, 2 cups times 8 ounces gives you what? 16 ounces, okay? So we figured that, 8 cups that I have right here in front of me. 8 cups times 8 ounces in each one gives me what? 64, okay? Okay, so now let's see how that looks like if we're like somewhere we need to go to like a baseball game. How much water would that be? Well, obviously they already sell the water the way it is, right? But that's 1, so that's 8, 16, 24, 32, 40, 48, 56, and here we go, last but not least, 64 ounces of water. So this is your recommended daily amount of water that you should be drinking. We all should be. Okay, boys and girls, another way that you would see an input-output table would be where they are creating, well, let me just read it instead of saying, a number pattern begins with the values shown. So they have 8, 9, 10, 11. It's going by ones. Now we're going to create a table that correctly represents the relationship, which is a big word here, between the position of the number in the pattern and the value of that number. Okay, so here they have given us the values. Okay, so the values would be 8, 9, 10, and 11. Okay, those are our values there. 8, 9, 10, and 11. Now, we need to figure out what the position and numerical expression is. Okay, well, it's a lot easier than what you're probably thinking. I know that on different tests that they give us, it says it's kind of confusing, okay? And I don't want us to get that confused. It's not that hard, okay? So here, what position is this? Like if we had a line and number 8 was first, what position is that? You're right, that's the first position. That's number 1. So position number 1, the value is 8, okay? Position number 2, guess what? Who has that? The value of 9. So I put position 2 there. Position what? Yep, you got it. Número 3, number 3, that value is 10. And position number 4, that value is 11. Okay, so what is my numerical expression? Okay, remember our position is the input, our numerical expression is the rule, and the value is the input. So here it's saying whatever I put, my position times or plus, because it's going up, blank gives me 8. Okay, so what is it going by? Since it's going up, we know that it's either going to be an addition or multiplication problem. Let's go ahead and pose it as a multiplication problem. 1 times 8 gives me 8. Yep. But does 2 times 8 give me 9? No. So I can rule that out. That will not be correct. So let's try our addition. 1 plus what would give me 8? 1 plus 7. Okay. So let's go ahead and try with position number 2. The second position plus 7, does that give me 9? Yep, it sure does. The third position plus 7, does that give me 10? Yep, it sure does. And the fourth position plus 7 gives me 11. Yep, it sure does. So here you see that the relationship between the position and the value, okay? When you're doing your numerical expression, make sure that you're testing it out before you're set on, oh, I know it's a multiplication, it has to be. Make sure you test it out with all of them so that you can see, okay? And sometimes you'll see a lot of problems that will have the position missing or the value missing. So you would have to use your numerical expression, also known as the rule, to figure it out. Well, boys and girls, I hope you enjoyed today's lessons on input-output tables. Don't forget to drink that water. Until next week, adios.